Hello again. This time let's have a look at some basic expressions and types and do a bit of coding and use the top level. Now, I'm assuming that you know programming from before. You know either C, Java, maybe Delphi, C Sharp, PHP, or any other language, either scripting or programming language. It doesn't matter as long as at least you are familiar with programming. Now, uh, if you have a look here, I'm still using the Cornell University material. We have the usual types that we have: the integers, booleans, float, string, or char for a character. Notice here that we have actually a boolean in OCaml that can have either true or false. The integer, the one they were familiar with. The float is a number with a decimal point. Strings are the usual strings, and then the characters. Now, for the ranges and for the maximum and minimum values of all of these, of integers, floats, and all that, please go back to any other OCaml reference or book. I'm not going to spend time on this. As I said before, I'm assuming that you are familiar with with programming languages in general. Now, this is the rules or the syntax. If you're familiar with the Backus-Naur form, with the BNF, um, we have some operators. If you want to look at these operators here, this minus here, it takes an int or a float and it returns its negation, right? Whereas the not is for the boolean. So not true brings back false, or not false brings back true. Whereas here, minus in front of um, a 1, an integer, brings back -1. And then for these are unary operators, and we have here, I'm sorry, we have the binary operators, the plus, minus, star, slash. These are for addition, subtraction, multiplication, and division. Notice now that we have a difference between the ones used for integer and the ones used for floating values of variables. So the one for the variable is actually followed by a dot or a period, star, a plus dot, minus dot, star dot, slash dot. You cannot use these for integers and you cannot use these for floats. The compiler will not actually like that and have the mod. It takes two ints. These guys here, these ones here have to take two ints and return an integer. These ones here take two floats and return their sum or difference or product or quotient, whatever. And then this one for comparison, two ints or two floats. This here for equality, so it takes two values, either strings or booleans or floats or integers or characters maybe. And this one here, the usual concatenation for strings. Please have a quick read through the evaluations and things like that, and have a look also at these operators. Remember the functional programming concept that we said everything returns a value, everything is an expression. So even these guys here, if you notice these sort of operators here, they also have a return value. So the minus here that used for negation, as we said before, it can take either an int and return an int. So that arrow here means it returns an int, takes an int as input, returns an int here, or a float and return a float, as we said here before in this table here, small table here. And then same for the not, takes boolean, return boolean. For the addition, this expression here means it takes two integers and returns an integer. The plus with the dot for the float, it takes two floats and returns a float. Likewise for the other operators. What else? Some syntax here, which is not very important at the moment. We'll come back to that maybe in due course. Now, how do we declare a variable in OCaml? The way we do that is using the keyword let. So remember, OCaml, by the way, has actually a list of keywords. One of them is the word let. Let id equals e. That's how we declare a variable. Let something equals something. Unlike Java or C, where we say int I or int x, semicolon, and then somewhere in the code we say x equals da da da. No, in OCaml we say let id equals e, and that's it. And remember when we said before, we said types are by default immutable, i.e. we will not be able to change the value of id unless if we redeclare it again. So for example, let pi equals 3 point da, 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 is a declaration. So a declaration indicates to the compiler to evaluate expression e, produce a value and bind the value to the name ID. So e here, they're just mentioning here, I explain this rule here. Yes. So what happens here is that uh, the compiler will evaluate expression pi. It will produce a value and bind that value to this. I'm sorry. It'll evaluate this expression here. Yes. Evaluate this expression here and then bind it to pi. And then some other rules for and some other questions and answers here for how we declare stuff. For example, if we want to declare a function, that's very easy to do, and if the function is recursive, then we need to use the keyword let rec, and then declare our functions. We'll come to that when we discuss functions. Enough talking. Let's get some code now. Going back to Johns Hopkins University website, School of Computer Science. Let's go to our top loop and then try to do a bit of programming. Now we are actually using OCAML version 4.01.0, and if we want to declare a variable, let's say let I equals 10, and by the way, to end a statement on OCAML we do double semicolon, and that's it. Now it's telling us that val I is of type integer and the value is actually 10. Remember when we spoke about type inference? Now we didn't actually tell it that I is an integer, but by default automatically it knows that I is an integer. This is quite powerful, and this is what we mean by automatic type inference. If we want a floating value, so you can say let x equals 13.2 for example, and set double semicolon, and that's it. If we use I somewhere after, when we say semicolon we end that expression, but if we for example say let me show you actually how to declare a variable and then use it in some code. So we can say for example let I equals 10, and then if I want to use it somewhere else I can say in, i.e. in the following, like for example I minus I for example, and end that, and that will return a 0. Remember when we said everything has a value, everything in the expression returns something. So this statement here, or this code here, will return a value of 0, will return the subtraction of I, or the value of I minus I. Now if I try to modify the value of I, for example I equals 3, I'm sorry, no, that's actually the comparison. I'm sorry, yeah, if you remember that when we said the equal sign is actually for equality here, that it's actually comparing now I equal 3, is that true or not, and it's telling me that's actually false. So as you can see, I will not be able to actually change the value of I. There's another trick that we can use, but we'll learn that in the future. And as you can see here, for example, let x equal 4 in x plus 3, and that will return an integer value of 7, as we saw here, exactly the same example. And then we can declare a variable let x equal 4 double semicolon, and then somewhere else we can say let y equals x plus 3, or then we can say x times x, and then we get the value, or we get the result. We can say here for example I times I, and that will be 100. As you can see, that's correct. I hope that makes sense. This is very simple simple code just to get you going. By the way, let's have a look at the string. So let's s equals, we don't have to say a string as we said before, string test, and then it's a string test. If I just say s, it'll just, I'm sorry, a capital S, I'm sorry, I don't know why. Say s, it'll give me back the value of s, or for a char, let's c equals g for example. If you want to declare more than a variable at the same time, we can say let, for example, d equals 22 and h equals 3.4, and g equals a char of j, and a string, let's say for example t equals some random string, and we can do that very nicely. Thank you very much for watching, and I'll see you next time.